हेलो गुड मॉर्निंग स्टूडेंट्स। आज की जो क्लास है, इस टुडेज क्लास विल बी डिस्कसिंग अबाउट certain important points, right? Like ladder problem, how to solve a ladder problem, then symmetric circuit related problems in capacitors, how we can solve it, and if possible balance and imbalance Houston breeze, and देखते हैं चलो आगे कितना हो पाते हैं। ओके, सबसे पहले लेट मी डू इनफाइनाइट लैडर प्रॉब्लम। इनफाइनाइट लैडर प्रॉब्लम। ओके, जैसे कभी कभी हमें एक सर्किट मिल जाते हैं जिसमें, let me take an example to make you understand that. Between A and B, there'll be many different types method. Okay, fine, a simple method is there to solve it. Let me take a circuit like this. It goes to up to infinity. C twice C, C twice C, C twice C. This is one particular type of problem. How we can find out the equivalent capacitance in this particular circuit? How we can find out equivalent capacitance in this particular circuit? Okay, अब इस सर्किट को गौर से देखो, आराम से देखो, ध्यान का साथ देखो। क्या देखोगे? C twice C, C twice C, C twice C, यानी इस तरह से जाते रहेंगे। C twice C, C twice C, तो keep on going like that. Okay, so ये जो part है ना, C and twice C, we can call it as the building block. You keep on adding it, going. Okay, तो इस particular circuit का equivalent capacitance कितना है? Okay, अभी मतलब going up to infinity means I can keep on adding any number I like. Okay, let it be on the back side or let it be on the front side. Equivalent capacitance of the circuit in all situations are going to be the same. I can add in the front also, like this. Okay, so in order to solve this problem, what we will do, we have understood one thing: C and twice A, this particular element, whether we add it on the back side or whether add we in the front side, the total equivalent capacitance of the circuit in both situations are going to be same. To solve this particular problem, first of all, let us assume let equivalent capacitance between A and B be X. Okay, हमने एज्यूम कर लिया A और B की बीच में इक्विवेलेंट कैपेसिटेंस कितना है? X है। यानी A and B, ये दोनों पॉइंट की बीच में इक्विवेलेंट कैपेसिटेंस कितना है? X है। यानी ये पूरा सर्किट को मैं X से रिप्लेस करूंगा। अब मैं कह रहा था कि ये जो एलिमेंट है C and twice C, इसको बिल्डिंग ब्लॉक, आई वाज टेलिंग इट्स अ बिल्डिंग ब्लॉक of this particular circuit. So I can add it on the back side also, I can add it on the front side also. If I add, how many I am showing here? 1 2 3. If I keep on adding any number, equivalent capacitance of the circuit should not change because it is showing it is going up to infinity, means any number can come. So an element of this kind, let me add between A and B in front, between A and B. What is that? Let me call these two points to be P and Q. I have added an element C and twice C. So now I have assumed equivalent capacitance of this circuit to be X. Then equivalent capacitance of this circuit will also become X because I am adding the same element in front. So that means equivalent capacitance between A and B and equivalent capacitance between P and Q will have to be the same. Okay, so in this circuit, what is equivalent capacitance between P and Q? Equivalent capacitance between P and Q. How much it is? These two are in parallel, then in series with this one. Equivalent capacitance between P and Q should also be X. Should also be X. So therefore, what is the equivalent capacitance between P and Q? Cp and Q. First of all, see, these two are in series, then in parallel with that. So these two equivalent, how much will become? 2IC into X divided by 2IC plus X. That is the equivalent of these two because they are in series. Then this particular part is in parallel with this one. So we'll have to add it with this. For example, I have got it like this. Okay. For example, I have got it like this between P and Q. That is C. And on this side, this is how much is that? 2IC X divided by 2IC plus X. Now they are in parallel. Therefore, equivalent capacitance between P and Q is sum of these two. That is C plus 2IC X divided by 2IC plus X. Okay. But equivalent capacitance between A and B was how much? X. And equivalent capacitance between P and Q should also become how much? X. That means this particular part should become X. Now CPQ is also equal to X. इसका मतलब क्या है? C plus 2ICX divided by 2IC plus X should become equal to X. So you can take LCM here. If you take LCM, 2IC square plus CX, 2ICX, denominator I'll take it to the other side, 2ICX plus X square. So 2ICX cancels. 2IC square plus CX, correct, plus 2ICX is equal to 2ICX plus X square. So for me, I have to get a value of X. How much will get? X square. Let me take it to the other side. Minus CX minus 2IC square is equal to 0. So this is a quadratic equation. Okay, X square minus BX plus C. We can easily solve that particular point. So see how much we'll get from here. See how much we'll get in this case. You can use X is equal to B square minus 4AC. B square, negative will become positive only. B square minus, and minus will make it plus 4. A is equal to 1, 4. B square minus 4AC. You use this one, wait a minute. X is equal to minus B plus square root of B square minus 4AC divided by twice. So how much will get? Minus plus C, B square means C square, minus plus 4, A is 1, and for AC is twice C square divided by 2 into 1. Right, like this you proceed. C plus, how much will become? 4 to the 8 plus 1, 9. 9C square will give you 3C divided by 2. So this will get 2IC. I am not using the minus sign. You understand, if I use minus C minus 2IC is minus. Okay, 2IC, so capacitance cannot become negative. So you got a value of X is how much equal to 2IC. So equivalent capacitance of this particular circuit was X, and which is nothing but equal to 2IC. Okay, this is how you can solve infinite ladder problem. You try with 2-3 more questions, okay, and let me know in the comment box whether you're following or not. Now let me show you something about symmetric circuits. Some complicated circuit arises, having some symmetry, and how easily we can solve those circuits. I just want to show you here with a simple example. You can take any example, and these circuits will be same in whether you talk about resistor circuit or capacitor circuit. Both are going to be the same. So let me take any circuit here. Let me not make it very complicated. Let me first take a simple circuit. Okay, let me do it like this first, so that it becomes easy for you to understand. Okay, this way it will become easy to draw for you to understand. In each part there is a capacitance. In each part there is a capacitance, and to make you understand the point, let me take all capacitance to be same. All capacitance to be identical. Okay, to tell how many capacitance, see it carefully. I am considering all capacitance to be identical, same. C, all are C, suppose. Okay. This diagram I can take it like this also. It appears that, let me show you, because students remains generally confused regarding this particular circuits, but this is very easy to solve the circuits. You just need a little bit of patience, and you have to be confident. Do not get scared seeing this particular circuit. देखने में कुछ डरावनी है, लेकिन solution बिल्कुल simple है, हाथी की तरह है, खाने का कुछ, दिखाने का कुछ. So whether you call the circuit to be like this or like this, both the circuits are going to be the same. This is same circuits. Okay, I can add one here also to make it look little more complicated, but let me show you this one. This particular circuit we can solve it many ways. Out of that, one way I will show you now. Okay, one way I will be showing you now. Symmetric circuits. So in this one, there are two types of symmetry: vertical symmetry and horizontal symmetry. Okay, so minimum there are. Okay, anyway, let me show you one method. If you divide this circuit vertically, then the left side and right side completely identical. You see it. If you divide it horizontally, upper side and lower side, they are completely identical. Identical means बिल्कुल same है. Okay, और इसको कोई some people call it a falling symmetry, यानी आप इसको पकड़ के इसमें join कर दो. Okay, तो ऐसा खोला हुआ था, ये बंद हो गया, जैसे इस तरह से था upper part, ये बंद हो गया. Okay, तो इसको falling symmetry भी कहते हैं. मतलब ये बिल्कुल आके यहाँ गिर जाएगा, ये आके इसकी जगह पर आएगा, ये आके इसकी जगह पर आएगा, ये इसकी जगह पर जाएगा, ये इसकी जगह. So ये falling symmetry भी कहते हैं. खैर कोई बात नहीं. If you see horizontally, upper side and lower side, they are completely identical. इसका मतलब, I want to say, we have to find equivalent capacitance between one, A and B. I want to say point 1 and point 2, they are exactly same points. Point 1 and point 2, they are exactly same points. यानी इन दोनों point का potential same होगा. This particular point 3 and this particular point 4, 3 and 4 are completely identical points. So 3 and 4 must have same potential. Okay. 5 and 6, they are exactly again. Okay, if you come from this side, first point. Okay, if you go the third point, if you go, this is the third point. Whichever way you think. Okay, you use a general IQ, so you'll understand 5 and 6 are completely identical points. There is a center point. Okay, this is the point number 7, let me call it as. Okay, so point 1 and point 2, they are having same potential. If they are having same potential, they can be joined. 5 and 6 having same potential, they can be joined. 3 and 4 have same potential, they can be joined. In fact, 3, 4 and 7, okay, will also have, 7 will also have same potential as 3 and 4, but that 7 point I'll not be talking it now. Okay, because I have said something about folding symmetry. Anyway, 3, 7, 4 all will be having the same potential. Why? If you go this way, 3 is exactly the midpoint. If you go this way, 4 is exactly the midpoint. If you go this way, 7 is exactly the midpoint. So all midpoints should have, means decide the number of capacitors and their values, decide the number of capacitors and their values, okay, are same. Okay, so these points can be joined. The first, let me call A. From A, I'll be joining 1 and 2. Just check carefully. I'll be joining 1 and 2. 1 and 2 I am joining. This is 1 and 2. These 2 points I have joined. If I have joined 1 and 2, then you see from A to 1, one capacitor, from A to 2, another capacitor, from A to 1, one capacitor, from A to 2, the second capacitor. This part I have done. Okay. Now from 2 to 3, again 3 and 4 I have to join. Okay. Join 3, 7, 4. All these 3 points you join. And the second situation. How many points? 3, 7, and 4 we are joining. Check it carefully now. 1, 7, 1, 3. Okay. 1, 7. This is one capacitor. 1, 7, 1, 3. 3 is there only. 1, 3, 1, 3, 1, 7, 1, 7. Similarly, 2, 7, 2, 4. 2 is here, 4 and 7 is there. 2, 7, and 2, 4. How many capacitors come? 4 capacitors come. Now on the other side, 5 and 6. What is here? 5 and 6. So we have already considered what capacitor. This one we have considered. This one we have considered. This one, this one, this one. These capacitors we have already considered. Okay. Then 3 to 5. 3 is here. 5 is there. 3 to 5. One capacitor. 7 to 5. 7 is here. 5 is there. 7 to 5. Another capacitor. 7 to 6, another capacitor. 7 is here, 6 is there. 7 to 6, another capacitor. 4 to 6, 4 is here, 6 is there. 4 to 6, another capacitor. Okay. So we have considered these 4 capacitors also. What does it remain now? Between 5 and B, 6 and B. From 5 to B, there is one capacitor. From 6 to B, there is another capacitor. This is the point to B. Okay. So what has become? They are all parallel. This is parallel, they are parallel there. Then all will be in series. So between A and B, this is the first capacitor to IC. This is 1, 2, 3, 4. Again 1, 2, 3, 4. Again 2 IC. This is B. Okay. Now they are in series. If they're in series, 2IC, 2IC in series, equivalent will become C. 4C, 4C in series, equivalent will become 2IC. Okay, so CAB will become C into 2IC divided by C plus 2IC. That is 2